Miss Huang here. So we are going to continue on the next part of our trigonometry. Okay, so looking here, we are trying to find the angle x, but to do that, we have to find this angle theta, which is the bigger angle, right? Okay, and to do that, first, let us maybe find this length. Okay, so let's call this length A, shall we? A for adjacent, because it's the adjacent of angle 38 degrees. So what do I have? Hypotenuse. So cosine 38 degrees equals to 9.2 over A over 9.2. So A equals to 9.2 times cosine 38 degrees, which will give me 7.2497. Okay, so A is this amount, so theta equals to cosine inverse of A over 15.3, which is cosine inverse of 7.2497 over 15.3, that is 61.7 degrees to 1 dp, which means that x equals to 61.7 minus 38, which is 23, is it? 23.7 degrees. Okay. Yep. Okay, so next we are looking at the y, which is over here. So all we need to do is to just take 180 degrees minus 90 degrees minus theta, which is 23.7. So y equals to 66.3 degrees. Yeah. Okay, then we need to find z. Z is found by, maybe if I were to find this length here, which let's label it as O, and then we take it minusing off the larger length. Okay, so O is, by Pythagoras theorem, equals to square root of 9.2 square minus 7.2497 square, which is 9.2 square minus 7.2497 square, 5.6641. Okay, and once I've gotten O, I can also use I need another O, so let's call this O2. Okay, O2 equals to 15.3 square minus 7.2497 square, which is 13.4734. Okay, so in other words, z equals to this minus 5.6641, which is 7.812 Okay, yep, so that is it for part D. For part E, let's take a look. Okay, I see that the triangle on the right hand side has more information, so it will be easier to use that to find x first, am I right? Okay, so let's take a look at the fact that this is the opposite, right? So x is the opposite, and then 8.6 is the hypotenuse. So using that, sine 38 degrees equals to x over 8.6, which means that x equals to 8.6 times sine 38 degrees, and that is 5.2946 or 7, round up, which is 5.29, okay, to 3SF. Okay, so after that, maybe we take a look at another length, but before we go into y, we need to find this length here in, let's call it a, okay, because a is shared between the two triangles and it will help us to find z and y. So to find a, we can use Pythagoras theorem, where we say a equals to square root of 8.6 square minus 5.2947 square, which is, okay, 6.77689. Yeah, so that is a. Cosine of 42 degrees equals to a, okay, over, okay, now we're looking for y. So we can use Pythagoras theorem to say that the square root of 9.1192, which is 9.12 square, minus 6.77689 square, and then I square root the whole thing, it will give me y. Okay, that would be 6.101, which is 6.10 to 3SF. Okay, and that is my final answer for x, y, and z. Okay. Okay, so next we are looking at a trapezium. This trapezium here shows angle x, okay, and an angle 62 degrees. Okay, let's see what we can do with that information. Okay, so if I were to draw a dotted line down here, which would make this a right angle triangle, one thing we can do is that we can find this angle here, which should not help that much. Okay, how about we find this length here. Yeah, so that we can get 3 point, because this one is 3.6 here, let's find this, let's call it a here. So tangent of 62 degrees equals to opposite over adjacent, which is a. So a equals to 3.6 over tangent 62 degrees, which is 1.9142. Okay, and then using this, I can say that this part over here, which is a2, let's say a2 equals to 7.8 minus 1.9142 minus 4.7, which should give me 1.1858, okay, 1.1858, okay, and so x, tangent of x equals to opposite over adjacent, 1.1858, so x equals to tangent inverse of that value, which is 71.8 to 1 dp. Okay, and then let's take a look at the y. Okay, I can use Pythagoras. So by Pythagoras theorem, square root of 3.6 square plus a2 square, which is 1.8, wait, sorry, 1.1858 square would be 3.792 GSF. Okay, yep, and that is all.